outside the window, and we are creating the Nifty Pros Articulator, which is our text-to-speech software application for our disabilities department here at Central. And here's our outline. You can just take a second to look at it. But basically, I'm going to talk about what our project entails, what our requirements are, and I'm also going to do a prototype demonstration of our project. Chris is going to talk more detail about the requirements of our project and how that relates to our design, and also about the feasibility of our project to make sure we can actually finish this by the end of next quarter. And Ryan is going to talk about quality assurance, and risk analysis of our project and how we can combat those kinds of risks. And just to introduce ourselves, we have Ryan Bulliard right here. He's our lead tester. I'm a Spencer Graphy, team leader and lead documenter. And Chris Hansen is our lead programmer. Our advisor is Dr. Boris Goblerchuk. He's one of our professors here in our computer science department. And our client is Wendy Holden, who's the program coordinator for Central Access. And Central Access is the name of our disabilities department, but it's just way shorter to say. So from now on, every time we refer to Central Access, we're referring to our disabilities department. And our project goal is pretty straightforward. We're trying to create a text-to-speech program to assist students in reading their class materials. And you think this is somewhat of an easy goal, but later on I'm going to tell you about the software solutions that Central Access is using right now and how it's not working very well in their workflow. So I'll just get out of the way here. Now the three pieces of software you see right there are either currently used in Central Access or are outdated and not anymore. Top one is Daisy, and that one is basically where you compile a PDF into an alternate format in its own Daisy format. The only problem is that it reads math equations awkwardly, so every time you cross say a quadratic formula, it would say begin mathematical expression x equals negative b plus or minus and less of n mathematical expression. And if you had a large page of these equations, it gets rather cumbersome. And also the reader that they give to students crashes fairly often, so it gets rather irritating. And finally, the content preparation in order to produce these Daisy files takes a long time to compile. To compile an entire textbook would take about between 3 to 4 hours. And they always run into some sort of a problem where it would have to quit compiling, so they end up having to recompile the entire textbook again. And you can see how this can be a 7-hour, 8-hour project for each textbook they try to compile. Balabolka is actually a high-quality reader. You can download it for free. The only problem with that one is that it can't read math equations. And if you're in physics or math departments and things like that, that might be a hard thing to sell. So we want our reader to read those math equations so that you can use those in those departments. And also, the whole program functions off of the clipboard, so you have to copy and paste the content into that window. The problem we saw with that is that it's not a very integrated experience. You would have to switch between different windows. So for instance, if you're trying to read from a PDF, you would have to select the whole entire page by doing Control A and then switching over to the window and then Control V and pasting it. And we didn't think that was very intuitive or at least time intensive. And lastly, PT Reader. It was actually developed by Dr. Gillenbeck, who retired last year, or rather earlier this year. And the problem with that one was that it was a Firefox extension, but it kept breaking after each Firefox release. And now they're on a rapid release cycle where after every 6 weeks they increase their major version number up by one. And it disables all the plugins that were already installed on the system. So Dr. Gillenbeck would have to go into the source code and change a few things and maybe change many things because apparently they change their API often. So he had to be involved with this to make PT Reader work. And even when it did work, it actually crashed fairly often as well, so it was hardly usable. But PT Reader could read math equations, and it could read PDFs, and also I found out recently it could also read DAISY files as well. So essentially our solution is basically a PT Reader sort of functionality. We're trying to make it more stable and also less of a maintenance nightmare that it was. So here's our description of our project, a little more details. We're implementing a text-to-speech desktop application. In the beginning of this quarter, we were planning on making a Chrome extension where you can just install from the Chrome store, and then there you have it. The only problem was that, for one, it didn't really match the kind of requirements that our client wanted. She just wanted her prepared books to be read properly. And most of those are done in PDFs, and as we will explain later, trying to interface with PDFs inside of Chrome is kind of a nightmare. And also, we wanted to utilize the content preparation capabilities of Central Access. So everything that Central Access has created, we want our reader to be able to read. And also, they've prepared other lists, for instance, acronyms. For instance, like NAACP, AARP, they've expanded those into all these different lists so that you can actually say the acronyms correctly. They have about 1,083 right now, so it's a lot of effort, and we want to utilize all that effort in our program. And finally, it's going to be used by students with print-related disabilities. And the reason why we didn't say, blind or visually impaired is because actually most of our disabled students who will be using our application can actually see the screen just fine. The reason why they can't read it as well as others is because dyslexia is kind of one big thing, and everybody kind of understands what that is. But there's also anxiety disorders. Some of them is introduced by post-traumatic stress and things like that. And also just a few other mental disabilities that involve not being able to read the images of each of the characters and parsing them into actual words. So we hope that with our application, we can use the oral feedback in order to help assist them in their reading. So our process model, we're using a modified Scrum development model. And our stand-up meetings are during our school week, so 5 times a week. And we just do it after our 9 o'clock class. And we maintain a product backlog and our sprint backlog on Trello. And our sprint lasts about 1 week, and we plan on finishing all the tasks that we signed to that sprint on either Friday or Saturday. And the reason why we chose our modified Scrum is because we expect our requirements to change rapidly. And this was actually definitely the case for our project because it was made official yesterday that we have to switch between Chrome extension to a desktop application after we discussed that with our client. And also our project is mostly innovative. Not innovative as in it's a completely new idea, but that we have to combine different elements in unusual ways. And also we have to try and make it into an integrated experience, and there isn't exactly tutorials out there on how to integrate PDFs into your application and highlight text and things like that. So we have to muck around with it a little bit. Our team is organized as a democracy, and we did this just because we believe we all have roughly the same skill level. So we've divided leadership roles among the 3 of us, and Brian is in charge of the testing process. We expect every one of us to add tests to the test suite, but Brian's going to be in charge of testing and make sure we're on the right track. And I arrange the meetings with our advisor and with our client. And I also make sure we check our documentation standards. So I meet usually the final editor in all of our iteration reports. I make sure that when we deploy our project to our client, and then at the end of the quarter, that we give her enough instructions and documentation so that she can maintain it on her own. And also when we code, make sure that we document our functions correctly. Now, Chris, our lead programmer, he's in charge of making sure we're using our coding styles as we agreed upon. And he's also going to check for cross-platform compatibility. The two platforms we're going to be focusing on are Windows and Macs, because that's what most students have. And he's just going to make sure our system works on both operating systems. So our programming languages, they were web-based, JavaScript, HTML, and CSS for Chrome extensions. But now transitioning into a desktop application, we're going to be using Python and a little bit of C to interface with some of the C libraries we need, which are essentially the client speech technologies and things like that. Our version control is done using Mercurial, and we're using a Bitbucket repository. And our project management and also our issue tracking is done on Trello, which is an online collaboration tool that's usually general purpose, but we kind of refurbished it to plan our sprints and also to track of bugs and which things are completed and whatnot. And Chris is going to talk in detail about our requirements.
All right. First of all, I apologize if I speak a bit softly. And before I get into this, there was a few requirements we haven't exactly listed down. Well, not entirely requirements, but I think you need to emphasize that we're not creating speech synthesis. We're working with the APIs that actually produce the speech. We are, in essence, creating an interface of sorts. Another thing, we're not doing character recognitions. We're reading in text, which has made our work much easier. Now, one of the first requirements that aren't one of those is that we have it cross-platform compatibility, primarily on Windows and Macs, simply because that's what most students use. Additionally, we need to read PDFs and web pages, again, because of what the students need to use. The PDFs will primarily be their textbooks provided by Central Access, the correct format, and the web pages will be for their other needs. Now, in addition to this, we need to read MathML equations. MathML is mathematical markup language. It is an XML format that basically records the information in a way such that it can be presented and generated. Such, as you can see from the two equations there, A equals pi r squared and quadratic equation. Sorry, I was thinking that for a second. These are, as you can see, somewhat complicated, and we need to be able to read them. We also want to read more difficult equations, at least going up to calculus, though that may take some time to figure out how to make the reader read them. In addition to this, we want to be able to speak acronyms as they were more natural, like NAACP will be pronounced NAACP instead of trying to pronounce it as NAP. And same thing for AARP. We don't want to refer to corpse. Now, additional features for user-friendly design is bookmarking. So if there's a particular passage or paragraph that a user wants to go back to, they can with ease. Also records the last section that they read so that they can find their way back after they've been alive for a while. Another easy use is the use of keyboard shortcuts, and hopefully we implement this so that they don't even need to change pages, as in they can just read it in its native form while the text reader is reading in the background, and they can control the rate of speech and playback there. We also want it to auto-update. This is important not only for updating the list of acronyms constantly generated by Central Access and their hard work, but we also want to be able to create updates in case, say, we are able to create more complex equations for it to read, or if there's some kind of compatibility issue that needs to be resolved, then the program needs to be updated.
So now I'm going to do a demonstration, and basically this is going to be a slideshow prototype, and we're going to just outline 3 use cases. The first one is selecting text and pressing play. I imagine most of our students are going to be doing that most of their time, so that's an important thing to outline what that actually looks like. And also loading and reading a PDF file. A lot of the prepared sources are text selectable PDFs, so it's important that our software does that. And also bookmark a selection for later reading in case they have a point that they want to discuss with their teacher because it was confusing, or a place they need to memorize a data table or something like that. So I'll go do the first case, selecting reading. So say you're in an introductory math course, and there's a section about solving quadratic roots without factoring. And it has the quadratic formula in there, and you want to be able to read that. So all you do is you select it just like so, and just copy it, Control-C or right-click and copy. And then in your window, you just right-click the main window here, and then just paste. And it kind of works like most text editors. And then it'll put it right in there. And then all you have to do is press the play button up there to play the text. And I actually have an example sound file of how that set of words should be read. So let me see if this works here. It's also done by UK voice, and it's kind of cool.
Solving quadratic roots without factoring. Sometimes it is difficult to factor a quadratic equation in order to solve for its roots. However, an equation has been established to solve these kinds of problems. The equation is called the quadratic formula, and it is the following: x equals negative b plus minus the square root of b squared minus 4ac over 2a.
So that's the voice. And during the time that it's actually speaking, it should highlight the different places that it is speaking. So I'll just show you what that highlighting will look like. So up at the header, it'll just basically when it reads paragraphs, it'll select it by per sentence time. And that way there isn't a whole lot of screen updates, and people might get distracted by that. So we thought just doing it by sentence is probably the least obtrusive way. And also on some other readers, when they read that header, they'll actually say begin header, solving quadratic roots without factoring end header, or begin bold solving and whatnot. And with ours, it'll just read the text as it is, because I doubt most of our students would care if that was bold or italics or important. So then it just goes through each line and just highlights them. But then when it comes down to the equation, it'll actually highlight each element. So as you can see, the x is highlighted, and then the equals negative b, plus or minus, and then when you see parentheses or a square root or something that holds multiple elements, it'll highlight the whole thing first and then go into the first element. So there's b squared, and the reason why that's split up is because sometimes you have more things in the exponent, and if there's another expression there, you can do that. So it's b squared minus 4ac, and we combined everything that multiplies together into one word, and we just thought that's how we normally speak anyway, so might as well let the software do that as well. And then over to A. So that's our conclusion of our first use case. So let's go on to the second one, and reading PDFs. So let's say that your English teacher just posted a copy of Moby Dick on PDF, and you just download it to your desktop, which is where it is right now, and you want to load that into our reader. So the easiest way that we imagine that you would do this is that you just drag and drop right into the reader. You can choose file open if you want, but I like dragging and dropping behavior a lot, and this is kind of a cooler diagram. So when the PDF is open, as you can see, it'll show the contents on there, and we plan on converting these PDFs not exactly into print format, but I forget the word, but it's where it's a continuous line, so that when you resize that window, the paragraphs, becomes smaller because there's more space and things. So basically, probably converting this into rich text format most likely. And as you can see down below here, you just got new controls because you're controlling a PDF now. And you can go backwards and forwards on pages and things like that. And up on top, and just to clarify what these buttons do, this is the stop button, so stop speaking, start speaking. And this is our looping button. So if you select a certain passage and you just want that to repeat over and over again for memorizing, or if you didn't get it the first time, you just press that button and it will remain depressed while it's playing, and then you can just press either that loop button again or the stop button to stop the looping. And finally, right here is our bookmarking button, and we chose the golden star because Google Chrome uses stars as its bookmarking button, and I believe also Firefox does too. So try to make it consistent with what people expect. So now to our third use case, bookmarking, back to reading Moby Dick. And you just read something on there and it seemed kind of interesting to you. This one, it wasn't really all that quite interesting. It's just about fossils and things. But if you like fossils, might as well bookmark it. So all you do is you press that bookmarking button right up there. And then when you do that, it'll add that to your list of bookmarks on the top level. And as you can see, it'll save both the PDF and also the page number of where that is. And most likely we might be making local copies so that when you double click on it, it'll automatically open up the Moby Dick PDF and turn it to page 322 as you bookmarked. Now, as you can see above that, there are folders where you can put your other bookmarks, and he just has it lined up by subject, but you can do whatever you want. So what our user is going to do, he's going to put this Moby Dick PDF and he's going to put it in the English folder. So all you do is just drag and drop right into it. And then as you can see, it's kind of right down there with our other list of literature classics. So that's all we have for our demonstration. Ryan's going to discuss about our quality assurance.
In order to ensure that we deliver a good quality product to our client, we're going to use several basic methods of quality assurance. What we're going to do is at the end of each iteration, we're going to give the client the program in order for them to test it, give us feedback, and list new requirements for the next iteration. This is to ensure we're getting constant feedback about how our program is doing and if it is meeting the requirements they have set out for us. Sample textbooks will be given to us by the client in order to test our product in an environment where the users will be using the same environment as us. We'll make sure that columns are read correctly in the textbooks and that tables and such can be read with ease in these textbooks. We're going to be using a structured ad hoc testing where even though we'll be free to test how we want, looking for bugs, it will have a list where you're supposed to follow it in order to ensure you test all the features. This list will start out fairly simple, such as will the program start up and will it read basic text. These will be tested however the user wants, whether Windows operating system or Mac operating system, as long as it completes the test. This is to ensure we get a wide variety of different samples in order to ensure our program works across various formats and different cases. As we add new features, a new test will be added to the list to be tested later. First, you would add the test to the list, and then you would test all previous tests to ensure all functionality is still there and was not removed when you added the new feature. Once all of the previous tests have passed, you finally test a new feature you added, and if it passes, you can work on the next feature. We have determined 3 major risks to making our project fail: time management, missing a worker, and incompatibility with our programs. In order to prevent misuse of time, we have determined that we will set aside an hour for each night to work on the program. This can either be working on the coding or the iteration report, whatever is needed to progress the program and project. If a user is missing, such as from an illness or a sudden death in the family, any tragic event that would cause them to miss work, we have determined that they should email us as soon as they can. And then the two remaining users will set aside an hour and a half to work instead of this hour in order to ensure that there's enough time to complete all features required of that week. If there is a planned absence, such as a vacation or a out-of-state wedding, the user that is leaving is expected to do their work prior to their leaving. If they're unable to do so, as if it is the end of an iteration and they don't know what is expected of them, the two other people will work an hour and a half each night in order to get the work done, and then the person who left will come back and do extra work in order to catch up and do a fair amount of work for the project. Since we are working across multiple operating systems such as Windows and Mac, we expect that we'll encounter at least a few incompatibility issues. We're mitigating this by using a Python coding, which works across multiple platforms. And if we do come across a incompatibility that we just cannot get around, we will alert the client to this issue, and they will determine if this incompatibility is a priority to get around, and if they determine it is a priority, we will list the requirements of getting this around and add it to the next iteration, where we will devote more time and resources to getting around this incompatibility. A few of the challenges we have faced previous to this talk is PDFs are a hard format for text readers. We have determined that Google Chrome, even though it supports opening PDFs, you cannot read text in a PDF format using Google Chrome. We got around this by converting the PDF into a HTML document or a rich text format document, which then when opened in Google Chrome will actually read it with a loss of formatting, unfortunately. For many websites, in order to use MathML, they decide to avoid coding and text-based MathML and use just images that look like the MathML. Unfortunately, this leads to a huge problem for us, which we cannot read images. If the client deems it that we really should read images, as if enough websites use this image MathML, we could provide a screen reader which will then convert the MathML into something we can read. Unfortunately, this is time consuming and it could be a major challenge for us if our client deems it necessary. And Chrome has poor MathML rendering functions, as in they do not render MathML at all on page sometimes, or they'll have like the code in the HTML but will not show it. So our reader will be reading the web page, and then it'll come to MathML and read it fine, but the user will not be able to see what our reader is reading. And now for Chris on feasibility.
First off, I know that we can't do this. We have had to make changes. For one thing, switching to Python. We switched to Python because it has the abilities that we need. This includes the C libraries, which will allow us to act with the SA APIs, as well as a certain amount of text-to-speech allowances within itself. And it's also cross-platform compatible, a very important feature. Now, another thing that how we know this is doable is that we've seen other programs do similar things. They haven't fulfilled all the requirements that we need, but they have done similar things, so no reason why we can't do it. And as a sort of fallback, if all else fails with switching to application, we can still produce a Chrome extension. It won't be as high quality or even as many of the requirements as we want, but it is still a possibility to give them something that's better than they have. And
so I'm just going to go about our concluding remarks. transitioning to a desktop application removes a lot of the hoops that we've been trying to jump through using Google Chrome. If we were to use client technologies within the context of a Google Chrome extension, we would have to somehow make what's called an NPAPI plugin, and that basically is kind of like a open framework by which you can make plugins. I imagine Flash was most likely programmed initially as NPAPI, and then anytime it comes up with a memory type as a Flash object, it'll load that NPAPI plugin, which is what everyone knows as a Flash player. And none of us have experience in this, so that was kind of not a possibility. And also JavaScript, it's kind of limiting by itself, except strictly in the web domain. So we didn't think we could accomplish many of our objectives just using JavaScript. And also, at least concerning Python, all the tools are available out there. I'm very sure there is a PDF rendering library. There's also a very good GUI binding. We're going to be using Qt. It was at one point owned by Nokia, but now it's owned by Digia or something like that. But that is a well-developed GUI network that has been developed for cross-platform on Windows, Linux, and Macintoshes for the past 10 years. So we hope that a combination of Qt and Python, we can achieve a cross-platform code base. And the only code that we would have to modify in order to access the client speech technologies would be in the C bindings. For instance, with Windows, we would have to access SAPI, and then with Macs, they have their own speech API as well. And also, just to reiterate what the purpose of our program is, we want our text reader to be easy to use, but we also want it to be stable and free maintenance, or at least as much as possible. So we want to be able to have an auto update feature. So it'll pull, every time they open the program, it'll pull to our server, which pull the changes if there are any, and then say if updates available, then they can click on it. And relatively straightforward, no nonsense, and everything's within the application itself. So at this time, we're opening the floor to questions. Do you have any questions?
So you're using Python on Windows, but Python is not normally installed on Windows by default. Are you going to bundle the Python library along with the Qt library?
Yeah, we're planning on just having a Python installer, deployed along with our application. I mean, that's pretty straightforward. It's just kind of all in a zip file, if you would. But
I noticed on your prototype you have a lot of menus up at the top, as well as that bookmark menu on the side. If somebody has a disability, how are you planning on helping them navigate those menus?
With the top menu, it's going to be mostly a keyboard. So you can press the Alt key, and then it'll underline, the first letter of each of the top header components. For the file, it'll be the F, and the edit will be the E. So you just press Alt F. So we're trying to make this work with keyboard shortcuts. So if you want to read it without having to press the play button, you can just do a Control-R. And then if you want to stop it and it's already reading, you can press Control-R and it'll stop it. And Control-L for looping it. Things like that.
So when you're developing an application that might be used in this department here on campus, it's nice to say, well, we think this is how it will be used, or we want the users to do this and that, but have you considered, or is it possible, I know there are guidelines in this, that you actually not only give this to the client, but actually give it to the client and say, could you please try this on some test cases, like have people use this? Because that's the best feedback that you're going to get. Not because it's hard to put ourselves in the mind of somebody who has a disability and say, well, we think they're going to like this.
Well, lately it's been kind of hard to actually create a packaged program that we can give our client to testing. And although we are a agile design and we should have something deliverable, it's been mostly kind of a research project concerning that. with Python, it should be much easier to, you know, iterate on builds. And I mean, we actually asked our client to have, you know, focus groups with her clients, and that the reason why we had the bookmarking feature was, you know, one of the features that one of the clients they had wanted. And also, I didn't mention this, but every time you close the window and then you open it back up again, it'll remember the last section that I read, and that was a direct consequence of the focus groups.
The looping feature was also a consequence of the focus groups as well.
Once we have a working prototype and we give it to the client, we will probably request that they try and get a beta testing group in order to use the program to say, okay, here's a prototype of a reader. Could you please tell us what features seem to be missing, or what can we add to make your experience better?
So, you say you're using MathML for these math equations. You have a PDF of a document. I don't know this PDF.
Yeah, we kind of looked into how MathML would be incorporated into PDF. I don't think the actual MathML code is actually present in the PDF per se.
So how do you get to MathML?
Well, MathML, it'll probably be from DAISY files. They use a certain form of math, and then you can export that math into MathML. And also, like, you know, Word documents. That's another thing we would like our reader to read. And those equations, you can convert those at least, you know, within the GUI into MathML. So we just need an interface with, you know, a sort of Office API, and then convert, you know, their math equations into the MathML that we can read.
So I'm still not understanding how you're going to do PDF documents.
So now that future is kind of uncertain concerning MathML. Central Access creates text selectable PDFs, and that's inherently different from you know, screenshots where the reader has to use OCR to figure out where the sentences are. After we get our sample books from our client, we'll just investigate whether there is MathML code present, but at this time, we don't quite know what the situation is with that.
Can I help you out on that?
Yeah.
As a client, we can produce Word documents that can be read instead of text selectable PDFs, the documents that have math. We have flexibility in the final formats that we require.
Yeah, they're very helpful. Any other questions?